Hi everyone, in this tutorial we are going to be creating the game Snake using JavaScript. Now you might have. Let's get started. Now we want our page to look like this, we want our canvas centered, and we want our title at the top. Now if you haven't really done game development before, well, we are going to be using something called a canvas, and the canvas allows us to draw to the screen. That's that dark gray area where our game is. And we create a canvas and ID Snake game. We are going to give it a width of 400 and height 400. Just to make it similar on each side, close that canvas over there. We are not showing anything yet because that canvas doesn't have a background color or anything like that. And then what we are going to do is we are just going to go ahead and add a little bit of CSS over here. Sorry. One tag Snake game and our style tag. Let's go ahead and style that body. We are just going to go ahead and set the margin 0 pixel and padding 0 pixel. You know, just kind of removing all this extra stuff that we don't need. And background color height 100 pip of height. We are going to use display flags. It's a way of arranging your items on the screen. We are going to say that flex direction of our flex is column, so we are going to stack our items one on top of another, and we are going to just say justify content to be center aligned and align item center. So we need our vertical and horizontal centering done, and then you will see when I click say snake will go in the middle and then canvas. As well as you might have noticed, the canvas that we have on the previous screen has this shadow. That makes it. And canvas. Set that to black, set that to firstly box shadow. And 20 pixel, 8 pixel and 50 pixel. What's that? We haven't applied a background color yet, but we are going to do that within our JavaScript code next. And h1 color. Okay. Get our canvas, so from our JavaScript we are going to use document get element by ID. And we are going to find that canvas on the page, and we are going to find that canvas by the identifier right there called snake game. And then we are just going to define a variable. We are going to call it a constant, and we are call it canvas equals in order to draw on the screen. What we are going to have to do is get a context from our canvas. We are going to call that ctx, and then we are going to ask the canvas as follows to get the context ctx, and we are going to ask for a 2D context. There are other contexts available. For example, if you want to draw in 3D, you would ask for a 3D context. All we need is 2D, so right there over here we get the canvas, ask the canvas for the context, and then we can use this context. The first thing that we are going to set up for our snake game is the game loop. The game loop is what's going to continuously update the screen. We are going to call it snake game. Now, three ways that we can do this is request animation frame set interval, which will give a function and just say continuously call this function every 1 second, every half a second, or set timeout, which only gets called once, but then we could call again. Now the reason we are going to use set timeout, which is maybe a little bit different. The set timeout is going to give us an opportunity to change how often our screen gets updated off the top of our screen over here. Let's define a variable called speed. I am going to say speed is equal to 8, then instead of our snake game function. What we are going to do is we are going to call set timeout and we are going to give it snake game function, which is ourselves over here, and snake game takes milliseconds in, so we are going to say 1000, which is equal to 1 second, so 1000 milliseconds is equal to 1 second, and divide that by our speed. Then our very last step that we need to do is to actually call snake game to get this game loop going. Let's go ahead and draw our background. So in order to draw our background, what we are going to do is inside snake game, which is our game loop, we are going to create another function called clear screen, and clear screen's only job is to go ahead and clear that screen. Let's do that, so clear screen. We are going to use that context. Now that context allows us to draw to the screen. We are going to say that it's fill style, which is kind of like a paintbrush. We are going to say your paintbrush is the dark gray. Now take that paintbrush and go ahead and draw a rectangle and fill it with that color that you have. And start at position 0x and 0y, 0. Now that's from this top corner here in the top left, and make the width, of that rectangle that you are going to draw the same as our canvas and same as our height of our canvas. At height, click save, and there we go, we have our dark gray background. Our canvas size is 400 by 400. So for this particular game, what we are going to do is we are going to establish that our tile count across is 20 and 20 down. So imagine little squares that you are moving through across the screen, and there's gonna be 20 going horizontally across and 20 going down. In order to do that, we are going to define a variable over here called tile count, and we are going to set that to 20. Then for our snake, we are going to create a variable called headx, which is going to be the x position of the head of our snake, and we are going to set that 10, so it's in the middle of the screen. And then we are going to set our head y to 10 as well. Now you can't really see these tiles, but if you imagine that there were 20 of them across and 20 down for x, we will count. Alright, so we just need one more variable before we can draw our snake over here. So we have our tile count. Included with our tile counts, we are going to have a tile size. So that's going to mean when we draw our snake or apple to the screen, we don't want it to take up the full 20 of that tile what we'd like to do is have it more like 80. If our canvas start over here divided by our tile count, so that will create appropriate number and 10, then take that tile count at -20. So canvas width divided by tile count is giving us 400 divided by 20. Which is 20, and then we are just going to -2 to make it just a little bit smaller. Now we can go ahead and draw our snake to the screen to do that. Let's go ahead and add the draw snake function inside of the draw game. So at that function dev and we'll go ahead and define the draw snake. And what draw snake does, it takes the context ctx sets as a field style, which is like a paintbrush, and then that paintbrush will be equal to the color orange. And we are going to represent our snake as a rectangle or as a square on the screen, so we are going to use fill rect. Give it the x and y position, so this is the important part, the x right there, and we are going to go times at x times and head rise times time counts the tile count, so that we'll position it within our tile map, and then we do head dot y times the tile count, and then we have two more properties. Those two more properties are the width and the height of our rectangle. Remember, we said that's going to be our tile size, so then I can grab our tile size and say the width is 18 and the width here is 18, because remember this is 400 divided by 20 minus 2, so that sets to 18. And tile size. Then we click save, and we have our snake right in the middle of our screen. We are going to do is go ahead and set two variables. The two variables that we are going to set are an x velocity and the y velocity. In order to change those values, we are going to be using our keyboard. So whenever you click the left arrow, the right arrow, the up arrow, down arrow, we are going to either increase or change the velocity of your snake. Now if you get left in snake, that means your snake will continue to move left until you either hit up or down. You are technically not allowed to hit right, because then you would go into your own snake body. Let's go ahead and implement some keyboard listeners for this. So what we are going to do here at the bottom of our file is we are going to say add event listener on the body. So add event listener or an event called key down. It's all lowercase. Then we'll create a function called key down. We'll just define rights here, and the key down function will listen for any key presses, and it will take in an event as one of its arguments. From that event we'll be able to determine which key was just pushed. One way we can do that is with a code, and this you can just Google and find out what each key code is. So for the arrows, various arrows here, the one I'm implementing is up. The up arrow has an event code. If event code arrow up, when you push the up key, what we are going to want to do is change your y velocity. Your y velocity will be equal to, and we are going to say -1. Y velocity equals -1, because your y will increase if you go down, but if you go -1 it will decrease. So we are going to say your velocity of -1, which technically we just want you to move one tile at a time up this way. Then also if you were moving in an X position, so along the horizontal plane left or right, all of a sudden you are going to stop moving left or right and only start to move up. So we set X velocity to 0 hitting. The up arrow on our keyboard won't to do anything just yet. Sure, it will change the Y velocity, but we are not using that value to change our snake position. To do that, right before we draw our snake, let's create a new function called snake position. So snake position call right here, then we'll go ahead and define our snake position. Constant snake. And snake position will change the head and the Y position, so head X equals and head X plus X velocity which could either be a negative number or positive number. This is perfect. This value can be a negative or a positive to move our snake head left or right. Let me do exactly the same thing for the head Y. Over here, say head Y plus Y velocity. And say that, then if you come, oh sorry, that, and X velocity, hit the up key, snake continues to move up. Let's scroll down over here to our key down event and go implement the down arrow. Down. So in order to implement the down arrow, the only difference is we need to make our Y velocity positive like that, and we need to change the code to the down arrow. Go back to our canvas over here and click down, push up, and now I can move our snake up and down on the screen for the left and right. All we have to do is change those X velocities and set the Y to 0. So let's go ahead and copy down over, change that code. So we are going to implement, let's go ahead and implement left. Left is called arrow left, and then for our X, because we are going to be moving left, we want to set our Y to 0 and our X, so X goes this way, which is negative, so -1. Then for our right might as well do that one right away. Go ahead and implement that one, put our right key code. Here we got right, the code is going to be equal to arrow right. Then make that one a positive. Now if we go back to our screen and push left, push right, push up and push down, it's perfect. Now our snake can move around on the screen. Of course, once we have our snake body, we are not really allowed to move up and down. So if we are already moving down, we are gonna have a body behind us, we shouldn't be able to crash back into our own body. So let's go implement some guards to prevent us moving in the opposite direction. Let's take that up. Key event over here, if our character is moving down, you should be able to move up because then you crash into your own snake body. If you want to move up but you are already moving down, that's not allowed. So to prevent that, we check if the velocity is equal to 1. If the velocity is equal to 1, we return and we just say you are not allowed to do this. By calling return, you are going to exit the keydown function. We can test that over here, so that if I am moving down, I'm pushing up, nothing is happening, and then we can do the same thing if you are asking to move down, but you are already moving up. So all you have to do is copy this if statement over here, put it here, and invert that value to a -1. So now that if I'm moving up and try down, that's not allowed. Then if I am moving right, I shouldn't be able to go left. To prevent that, it's exactly the same but just on the x plane. So x velocity equals 1, then we go over here. So now I'm not allowed to go left, I'm already moving right. We'll do exactly the same thing for the right key over here, and then we just set that to -1. Now it doesn't make as such sense when you don't have a snake body like this. You don't have any yellow items behind you, but normally in snake you will have items behind you. There we go. We have implemented same guards and made this more true to snake. Let's get apple on the screen so that we have something to collide with and grow our snake. In order to do that, let's go ahead and add some more variables, so kind of like our head x and head y. We are going to have an apple x and apple y. Let apple x equal to 5, and we'll let apple y position also equal to 5. Inside a snake game, we'll add a function called drawApple. Go define drawApple below so function. DrawApple, and actually I'll move that over here away from change snake position. So that we have drawApple, and what we do once again is we use ctx. We use field style. This time we are going to say field styles is set to red, and we are going to define our apple just like we defined our snake as a square. So we are going to use field rectangle. We are going to use position apple x, and then position apple y. Then what we'll do is we'll set the width and the height, and that's just going to be our tile size, so just like our snake. So tile size and our tile size and click save, and now we have an apple on the screen. But remember that apple that we just placed, there is an x in y position. We need that to be within our tile count of 20 across and 20 down. So to make that work, what we do is we take our apple X over here and then for apple Y do the same thing times tile count, which will move us down on the vertical plane over here. So we are position 5 5 on the tile count and the snake is at position 2020. Next we want to check if our snake collides with the apples, as you can see. Right now, when the snake goes over the apple, nothing happens. In order to do that, we are going to create a new function called check apple collision. This function will go over we change well after we clear the screen and snake position. Check apple collision. We are going to create a new function, but before we draw that apple, what we'll do is we'll do check apple collision and we'll go implement that below over here. So check apple collision function. And what we are going to do is we are going to say if the apple X is equal to, if apple X equal to the head of the snake's X position and the apple Y is equal to head of the snake as well. Apple Y equal to head Y. Then that we are going to do is change the apple X and Y position and draw a new apple in a new spot, which effectively makes it looks like our apple disappears. To do is let's set our apple X position equal to some random number. We are going to use matfloor to round down and then matrandom to give us a random number between 0 and 1. We take that number times it by our count, which will be the max number that we can get, which is 20 because our tiles across our account of 20 tiles, and then our Y we are gonna do exactly the same thing. Instead of apple X we do apple Y, click save. Now when I move my little snake here and I hit the apple, you will see that the little red dot keeps changing positions whenever they are the same. We have just implemented collision. Let's do that. Detection with our apple with collision detection implemented. Our next goal now is to increase the length of our snake. To track the length of our snake, we are going to use a class what we are going to create called snake length. Snake length will define right here. At the top of our file, and we'll just call it snake length, and snake length will take a constructor that has an X position and a Y position, and then in the constructor we'll just set those values. And then we are going to set up an array. So in addition to tracking our head and X over here for the snake, we'll just define a little array called snake length. That's equal to an empty array like that, and we'll make it constant because we never removed this array. We only modified the contents of it. Let's also create another variable over here. After snake length called tail length, now this will be the length of our snake tail. Tail length. Even though if we have our snake length array, you will see why this comes in handy over here. And let's set that to 2. So when our snake gets moving, he'll automatically have 2 tail pieces using this new tail variable. We are also going to go into our check apple collision over here. And if there is a collision with the apple, what we are going to do is we are going to increase that tail length. So tail length plus plus. Let's go ahead and draw the part length of our snake going up into our draw snake method. Those body parts that we are going to be drawing are going to be the color yellow. So remember, our fill styles kind of like a paintbrush. Then when we loop over these items over here, what we are going to do is just do a little for loop. We are going to say let I is equal to 0. Well, I is less than our snake length because those are all the parts of the snake. The length of that array and incremented that then what we are going to do is draw the snake length. Now it's almost like this over here, so we could just copy that ctx field, but first thing we need to do is we are going to say let part equal to snake length. We are going to get the item from that array, so this represents our part, and then we could do ctx dot field vect, and we are going to give it the part dot x. And remember, because our snake comes from this class, the snake part, and it has an x value and a y value, so back in our draw snake over here we can say part x times our tile count and part dot y times our tile count. Part x times tile count and part y times tile count. Then the size of this, remember, is just our tile size that we used for the width and the height. Now here is the part. Tile size. That's going to seem a little bit like magic, so when we move our snake, there are no parts right. No parts are being added to our snake at all, even though our tail length is 2. Now, the way this is going to work every time we draw the snake, we are going to go ahead and push a snake length and on one snake length at a time. Snake length push. Now that snake length that we are going to push on, we are going to say snake length stop. Push and the new snake length, and we are going to put it on in the position of where the head x was. Is look, we have already drawn our head over here. Head x and head y. And we are pushing this part on, we are finished drawing the parts, and now we are pushing this on, so the next time we come here and draw it, it's going to be where the head was, not where it currently is. We give our snake parts a head X and head Y so that the X and Y position of the head was then the important part as well. Depending on how we build this game and the way we are building it, here is we could just do an if statement, and if we could say that if our snake length dot length dot length greater than our tail length. Right now then remove that snake item, so we could say snake length, and what we are going to do is we are not removing the last item in the list, we are going to remove the first item in the list. The first item in the list is going to be the oldest item, it's going to be the furthest away item from the head. Every time we put new items into our list, they are being drawn kind of in reverse. Snake length shift is the very last item in the list, that's always next to the head because we push it on here, so this can be demonstrated right here. If statement, you could do a while statement if you were implementing a game where your snake, as soon as you crashed into a wall or ate yourself, then it would penalize you and make your snake back to its original size if you were to reset that tail length. So interesting, instead of doing an if statement you can do a while. You will have the same effects right here, but it opens up you to new gaming possibilities. It's always removing an extra item that we have that gets drawn. Let's go ahead and implement that score text what we had. So for score we are just going to create a variable and let score equals to 0, and we'll create a function called draw score, and that function draw score we'll be using the CTX to draw to the screen, but this time it's going to draw text with just the CTX dot field style, and field style is going to be equal to color, right? Because remember, that's kind of like our paintbrush, and we have a CTX font, we use 12 pixel and we use Roboto. After that, then we will also do CTX fill text, and use score space plus score canvas dot width -65 and 16. Then we need to position it, so we need to give it an X position and a Y position. We say canvas dot width because we are going to put it up in the corner over here, and then we are going to minus a number, and I played around with this early event 65, look pretty good. And then Y position, we are going to set that. Then when I click save, you can see that now we have a score over here on our screen. Whenever we eat an apple, we'll need to increment that score. Score plus plus. Now whenever we eat an apple, yes, score plus plus will increase. Let's implement our game over logic. The way this is going to work is inside our snake game. We are going to move the change snake position to the very top. First thing that we do before we clear the screen, then after we change the snake position, we are going to check if any game over events occurred. Did you hit a wall? Did you hit yourself? If you did, we are going to stop the game, and we are not going to draw or remove anything from the screen. We are going to show you if you were you went wrong, and then display the next game over. This is what the logic will look like it. That we are going to implement. We are going to create a result. Let result is equal to is game over function. If that result is equal to true, if results is equal to true, which means it's game over, is return. We are going to return. This means that we'll stop looping. We are no longer going to draw our game, and you are going to see the last thing that occurred on the screen. Let's go ahead and create that function. So function is game over, and then inside is game over. What we are going to do is define a little variable called game over. Let's game over is default false. So game over is equal to false by default, and then we are going to check a whole bunch of conditions. So first let's check those walls. If I am hitting, let's say left, and our x position becomes less than 0. If head x less than 0, then I'm going to say that game over, and then game over equals true. Game over is true. And at the end of our function over here, we'll just return game over, and then if I move up. So let's show some text on the screen. This return statement that we have over here returns, and then when it returns, it just stops execution of the snake game method. But before we do that, we are just going to put some text on the screen. If game over is true, and we use ctx field style white, ctx font 50 pixel, and roboto, and ctx field text game over, and canvas 6.5, and canvas width 6, and canvas height. Make our text look really nice. So if I remove that and say what you will see if we get that game over event, it's going to show that text on the middle of the screen just in white like that. And what we are doing is we are taking our canvas, and I just took this arbitrary number of 6.5. I took the width of our screen divided by 6.5 to kind of figure out where to put this. And then for the height of our game over, where to put this text, what I did as well is I just took half of the screen height and kind of arbitrarily put it there. The font size is 50 pixels and the color is white. Let's implement the rest of those boundary checks that we need to do. So if your head x is greater than, and we want to go to the greater than right over here, well, we have tiles. We know that there is 20 tiles across. So if you are greater than the tile count, that means that it's game over. If head x greater than tile count, game over equals true. So let's give that a try, and if we go over our game pauses just a little bit late, so we could say if game over is greater than or equal to, and then do that. and that works just perfectly and stops us at the right time. Additionally, why the greater than when we can just check if it's just equal to that number and go over equal and go over and it stops there. Then we can implement our y positions and we'll change this to an if else because as if there is no point of checking them another time. Head y less than 0, game over is true, and head y tile counts and game over is true. And just like our head x, when we are moving downwards, it's the number of tiles 20. So we could really just kind of copy that and change that to head y, and then that boundary condition would work as well. If we head on up, we crash right, that is, and it's game over, and push down, okay. And the important thing to note is we can see the last thing that we did. We know that where the head was pointed right before we went wrong. Another aspect of snake is that you can crash into your own body. Check. That you can crash into your own body when you collect enough pieces. Your body length becomes longer and you are not supposed to be able to go through your own body or collide into it right now. I cannot. There is no consequences, but it should be game over. Let's go ahead and implement that. After overall check, what we are going to do is go ahead and loop over all distinct parts. Let me say for let's I equals 0 and I less than snake length dot length and I plus plus, and then what we'll do is grab one of those parts, solid parts, equal to grab that part, and this is the most important part right here. Snake length grab we are going to check if that part x position is occupying that head x position, so where the snake head is, and if that part y position is also occupying the same space where the head y position is, and since they are both numbers we can use triple equals. Then what we do is we say game over is equals to true, and to break out of this for loop we call break, so we stop looping. If part dot x equals head x and part y equals head y and game over equals true and break. Now if I click save, what you're going to notice is we automatically get game over. Well, our tail size right now is 2, so as soon as we start drawing the game, technically one of our tail items is still occupying the same space our head is, but the game hasn't really started. If the game hasn't started, we can say and if x velocity equals 0 and y velocity equals 0 and game over equals false. And return. And we'll just put those in curly braces as well, like that, and move that. That if that happens, you can see we are no longer getting a game over. Now we can go ahead, eat a couple apples and see. Okay, if we are able to collide into our own body, you can see I was about to collide into my body over here. One last thing that we could do is increase the difficulty depending on your score. To do this will make the snake more faster. Now how do we do that? Well, we control the snake speed with set timeout. Right now we just draw the screen 8 times every 1 second. Because our speed is set to 8, if we increase that speed we are going to draw the screen more times every second. Which means that our snake will move faster. What we can do over here in our snake games is we could say if our score is greater than 10, if score is greater than equal than 10, speed is equal 10, and if score equal and greater than 15, speed equals 15. And then if our score is greater than 15, then we will increase that speed to 15. We will save that, then I will give it a try that. So right now my score is 1 and that's 8 times a second. Okay, 2, 3, 4. Anyway, so right now which levels your speed increases, you can flash something on the screen to say speed increase as that occurs. And yeah, it's just one little thing that you can do to make your snake game a little bit more challenging and a little bit more difficult. If you'd like to see more of these videos, please subscribe my channel, like and share this video.